we look at the partial derivative. So recall back, okay, the f prime x or dy dx by definition is actually given by limit of f x plus delta x minus fx divided by delta x. So similarly, for the first partial derivative of f with respect to x and y are the function. Okay, this is partial derivative, means when you differentiate respect to x, y is constant. And fy is actually when you differentiate respect to y, x is constant. Okay, by definition, fx is actually because y constant. So with the similar notation, we have the function of x and y. Okay, this one, another notation is actually del f del x. Del f del x. Okay, it's actually limit of fx plus delta x, where y is constant. So minus fxy divided by delta x. So for fy, another notation is actually del f del y. It's limit of the fx. Now x is constant. Y plus delta y minus fxy divided by delta y, where the there's delta y going approaches 0. So this is through the definition of partial derivative. So mean fx you treat y as constant, while fy you treat x as constant. Okay. Okay, for example, find the partial derivative of fx and fy for the function. Okay, we are not using that that limit notation. We are just straight go straight differentiate, mean to find fx, you differentiate respect to x where y is constant. Okay, so now you want to find fx xy is actually we del del x 3x minus x squared y squared plus 2x cubed y. So for differentiation, addition, subtraction, you can just is actually follow the linearity property where you can break it term by term. So mean you del del x 3x, so minus you del del x x squared y squared plus you del del x 2x cubed y. So del del x 3x, like you did the x 3x, but now y is constant. So del del x 3x you have 3. Okay, when you del del x, y is constant. So this y squared is constant. You have constant time x squared. So you can factor out that y squared because it's constant. So you del del x, x squared. So here 2 times y is constant. You can factor out. So you have 2y. And then you del del x 2 x cubed. Okay, you have 3. So del del x, x squared is 2x. So 2x y squared. Okay, del del x, 2x cubed, we got 6x squared. So you have 2y times 6x squared. So 12x squared y. So this is a fx. Or sometimes they put del f del x. So the same notation. Del f del x or f subscript x may differentiate respect to x while y is constant. Okay, before I proceed to the fy, do you have any questions or not on the partial derivative here?
So far, no, Doctor.
Yeah, okay, thank you. Okay, if no, okay, we'll just change it. If fy, okay, I just change x here to y. Here I change to y, 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 y. This one have to change. This one have to change. Change. Okay, so if fy is actually del f del y, so this is fy, this is del del y, del del y, del del y, del del y. So del del y 3x. When you del del y, x is actually constant. So differentiate a constant, you will get 0. So this term is 0. So when you del del y, x squared is constant, so factor out x squared, so you del del y, y squared. Del del y, 2x cubed is constant, so factor out 2x cubed. So del del y, y. So 0, so you have minus x squared. Del del y, y squared, you got 2y. So del del y, y, you have 1, so you get 2x cubed. So the answer is 2x cubed minus 2x squared y. So this is fy or del del y. Okay, any questions here? Okay, if no, we proceed to another example. Where is here? Okay, for z equal to fxy, the partial derivative fx and fy are denoted by, okay, either you use fx del f del x, because f also equal to z, also del z del x, or delta x fxy also equal to zx. So, okay, a lot of notation there. So fy or del f del y, cause f equal to z, also del z del y, or del del y the fxy, so you get zy, cause del z del y or zy, del f del y or fy. Okay, if we evaluate the first partial derivative at the point okay, AB, okay, if we use this notation del f del x, then a vertical line point AB. If we use a fx, then bracket A comma B. So similarly for del f del y. Okay. And then for fxy equal to x exponent x squared y, find fx and fy and evaluate each at the point 1 ln 2. Okay, fx. So exactly you would like to do del del x, the fxy, which is x exponent x squared y. So here you have the product form of function of x. So you need to use a product rule where you let u is x, the v is exponent x squared y. So your del u del x, which is 1. Del v del x, differentiate respect to x where y is constant. You have 2xy exponent x squared y. So that's why your fx, using product rule u del v del x plus v del u del x, you got x. So x total is 2x squared y exponent x squared y plus exponent x squared y. Mean x times here 2x squared y exponent x squared y, v times del u del x. So this is fx. Okay, and then if you want fy, fy is actually, and then evaluate at the point 1, 2. So fx at the point x is 1, y is ln 2. Okay, I can factor out. this one, x is 1, y is ln 2. Okay, factor out here same term, 1 plus x is 1, so 2, 1 squared, y is ln 2. Okay, exponent ln e ln 2 is 2. So 1, 2 ln 2. Okay, or you may change to floating point, okay, by pressing 2 plus 4 ln 2 in your calculator. Then I factor out this term, exponent x is 1, y is ln 2. So exponent ln 2, you get 2. So this one factor out is 1. Just left 2x squared y, 2, 1 squared y is ln 2. So this is 2 ln 2. Okay, so this is a result, okay, for fx1 ln 2. Okay, for fy mean you del y. Del y x exponent x squared y. Okay, for del y, okay, this is x. When you del y, x is constant, then you just factor out x. Okay, no need to use product rule because x constant, factor out. Then you just del y exponent x squared y. So you have x. Okay, differentiate respect to y, 2xy. So again, 2xy. Sorry, different is x squared. Wrongly differentiate. Okay, delta y. Okay, when delta y x squared is constant, mean let's say if you dy exponent 3y, you get 3 exponent 3y. So the x squared is like a constant value, let's say it's 3. So you get x squared exponent x squared y. So total is x cubed exponent x squared y. And then evaluate it at the point 1 ln 2. So x is 1 cubed exponent 1 squared ln 2. So e ln 2 is 2. 1 cube is 1, e ln 2 is 2. So for fy 1 ln 2, we get the answer is 2. Okay, so so far any questions here? No question. If no, we check.
Sorry, doctor.
Yes.
Uh, Doctor, Google recording on this lecture.
Yes, yes.
All right, thank you.
Correct. Just now. 2 plus 4 ln 2. Okay, and then the higher order partial derivative. Okay, just now we just see the first case. We just see the first case. Partial derivative. Now let's say we have the higher order partial derivative. Why again? Why not moving? Okay, for example, we have here. We already have this is second partial derivative del 2f del x2, or the subscript notation is f xx. So if we have fyy, fyy is actually del 2f del y2, or you del y del f del y. Okay, or you have the mixed derivative fxy. So for subscript notation, it's actually we differentiate fx first, later on fy. So exactly you have here. Okay. So when you see the sequence fxy in the del notation is actually del 2f del y del x. It's differentiate x first, later on y. Fyx mean differentiate y first, later on x. In the del notation is actually del 2f del x del y. Mean okay, from differentiate y, okay, y later on x. Okay, and later on you can see fxy should be equal to fyx. Okay, for example, find the second partial derivative of 3x y squared minus 2y plus 5x squared y squared and determine the value of fxy, which is negative 1, 2. Yeah, so fast. I don't want. Go back. Okay. Second partial derivative. First of all, to get the second partial derivative, first of all, we find the first partial derivative fx. Okay, is del del x 3x y squared minus 2y plus 5x squared y squared. So you del del x, okay, you can del del x each term. So del del x 3x y squared. So minus you del del x 2y plus you del del x 5x squared y squared. So when del del x y squared 3y squared is constant, you may factor out 3y squared and then you del del x x. Okay, so del del x 2y, okay, you get 0 because when you del del x y is constant. So del del x 5x squared y squared, 5y squared is constant. So you may factor out 5y squared. Yeah. So you factor out 5y squared. Then you del del x x squared. So del del x x, you have 1. So you have 3y squared. Second term is 0. Then del del x x squared is 2x. So you have 5y squared times 2x. So total you have 3y squared plus 10xy at 10xy squared. So for fx, okay, if the first time you may do it slowly. Okay, when you do a lot of time, you are okay very fast. You can straight away okay get the answer. Okay, for fx 3y squared. This is 0, 10xy squared. Okay, if you practice a lot, you may quickly arrive at this answer. And when I del del x, okay, this is constant, this is constant, so I get 3y squared. Differentiate constant 0. Okay, this is constant, this is constant. Differentiate x squared is 2x, so total 10xy squared. Okay, when you familiar already, you may get the answer quickly without going through the process. Okay, and then if fy, I erase it. Okay, for fy, similarly, if you have fy is actually you del del y 3x y squared minus 2y plus 5x squared y squared. So when you del del, okay, break one by one. So del del y 3x y squared minus your del del y 2y plus you del del y 5x squared y squared. So when del del y x is constant, so 3x is constant, you can factor out. So you have 3x and then you del del y squared. So minus del del y 2y, you have minus 2. Del del y 5x squared is constant, so you have plus 5x squared and then you del del y squared. So del del y squared, you have 2y. So minus 2 plus 5x squared del del y squared, you have 2y. So total is 6xy minus 2 plus 10x squared y squared. Okay, you familiar? Okay, you can quickly do it. Okay, let's see, you check the answer. When you del del y, okay, when del del y, okay, 3x is constant, so you del del y squared 2y, so 6xy. Okay, this one you get negative 2. When you del del y, this is constant. Del del y squared 2y, so total 10x squared. Oh, so this is, yeah, wrong. Del del y squared is 2y. 2y. So 10x squared y. Yeah. Del del y squared 2y. In constant, okay, write down, differentiate y squared 2y. So the answer is 6xy minus 2 plus 10x squared y. Okay, we want the second partial derivative. Second partial derivative. So mean we want fxx, fyy, fxy, fyx. Okay. No, I have to, no place to. Okay, I will jot down on top. The fx is the 3y squared plus 10x y squared. And then the fy is actually 6xy minus 2 plus 10x squared y. Okay, now I want fxy. Okay, I want fxy. It's actually I delta x fy. So all here I have to erase. Okay, I want fxx first. Okay, let's say I want fxx. So I delta x fx. The fx is here 3y squared plus 10xy squared. So delta x 3y squared, when you break it one by one, delta x 3y squared plus you delta x 10xy squared. So delta xy is 0. Delta x, okay, where 10y squared is constant, you factor out 10y squared. And then you delta x 10 delta x x. Yeah. You factor 10y squared delta x x, which is 1. So you get this is 10y squared. Delta x x is 1. So the answer is 10y squared. So fxx you will get 10y squared. Okay, and then if you want fyy, okay, so I put down the here f x, the answer is 10y squared. Okay, now we do fyy. Okay, fyy. So it's delta y fy. Okay, fyy is actually delta y fy. Okay, where the fy you have, just now you have jot down here, 6xy minus 2 plus 10x squared y. So your delta y 6xy minus delta y 2, delta y 10x squared y. Okay, when delta y 6x is constant, you factor out 6x and then you delta y y. Okay, delta y is 1. Here you get 6x. Delta y 2, which is 0. Okay, when delta y 10x squared is constant, factor out. So 10x squared. Delta y, which is 1. So you have 10x squared. Okay, so we jot down. Fy is 6x plus 10x squared. So you check Fy from here. 6x plus 10x squared, correct? Okay, later on, if we want to do, okay, find fxy, it's actually we del y fx. Mean from fx here, differentiate respect to y. Okay, so here I have got to erase. So 10y squared 6x. So here I erase it. Oh yeah. Do it. Everything gone. Never mind. Here it got. Okay, just now fx, fxx, fy, fyy. Okay, up to here. Just now we already solved up to fyy. Now we want jot down back. Because okay, just now you have the fx 3y squared plus 10x y squared. Then the fy is 6xy minus 2 plus 10 x squared y, and then we already solve the just now fxx. Okay, is fxx is 10y squared, and then we already solve fyy is 6x plus 10x squared. So we are going to find fxy and fyx. Later on, fxy negative 1 to 2. Yeah, put it here to prove this one. So the fxy is actually you del y fx, which is you del y, okay, fx here, 3y squared plus 10xy squared. Okay, mean you del y term by term, del y 3y squared plus you del y 10xy squared. So delta y 3y squared, you have 6y. Okay, when you delta y 10x is constant, you can factor out 10x and then you delta y squared. So you have 6y, delta y squared, you have 2y. So total is 6y plus 20xy here. Okay, this is fxy. Okay, if you want fyx, okay, fyx is, okay, I got to erase. Okay, fyx, okay, this one I got to erase. The red color. So if fyx is actually delta x fy. Okay, it's from here. Already fy later on differentiate respect to x. So it's delta x fy is here, which is 6xy minus 2 plus 10x squared y. So you delta x term by term, delta x 6xy. So minus you delta x 2 plus you delta x 10x squared y. So delta x 6xy, where the 6y is constant, you factor out, and then you delta x x. Okay, delta x2 is 0. Okay, delta x 10x squared y, where the 10y is constant, you can factor out 10y, and then you delta x x squared. So delta x x is 1, so you have 6y. Okay, this is 0. Delta x x squared, so you have 10y multiplied by 2x. So we have 6y plus 20xy. So you will see, okay, we always get fxy is always equal to fyx. Okay, and later on they want fxy negative 1 and 2. So plug in y is 2, plug in x is negative 1, plug in y is 2, you evaluate it, you get the answer which is negative 28 here. So this is about the higher derivative. We up to second order. If you want third order, similar thing. Okay, so do you have any questions here? Okay, no see. Oh, no more. So we have done. Okay,